In the vast, enigmatic depths of our planet's oceans, countless wonders lie hidden, waiting to be discovered. But sometimes, what we uncover isn't a marvel, but a warning. Our journey today takes us to one of the most vital, yet increasingly imperiled, stretches of water on Earth, the Gulf of Mexico. A place of abundant life, vibrant ecosystems, and a cornerstone of America's seafood industry. Or so it once was. For decades now, a silent, unseen killer has been expanding beneath its surface, creating a colossal void where life struggles to breathe, a phenomenon starkly known as the Gulf of Mexico Dead Zone. It's a mystery not of what lurks in the shadows, but of what has vanished, leaving behind an oxygen apocalypse. How could such a vibrant ecosystem simply die? What forces are at play, orchestrating this annual tragedy? Can we ever truly unmask the silent assassin that claims these waters? This is Ocean Mystery Case Files, and today, we open the file on the Gulf of Mexico Dead Zone. Imagine plunging into the ocean, only to find the very air around you slowly, agonizingly, thinning. That's the reality for millions of marine creatures caught within the dead zone. Scientists call it hypoxia, a condition where oxygen levels in the water drop so low that most aquatic life cannot survive. Below a certain threshold, the water becomes a suffocating trap. The evidence of this ecological collapse is chillingly clear. For over 30 years, researchers from institutions like NOAA and Louisiana University's Marine Consortium have meticulously mapped this vast, expanding region. Using sophisticated sonar, specialized sensors, and remotely operated vehicles, they paint a devastating picture. Instead of vibrant reefs teeming with fish, they find barren seafloors, littered with the ghostly remains of those who couldn't escape. The waters, once teeming with life, become eerily quiet, a vast, silent graveyard. These scientific instruments reveal a massive, seasonal expanse, sometimes growing to the size of New Jersey, stretching across the continental shelf, where oxygen concentration dips below 2 mg per liter, the critical threshold for most marine organisms. It's not an isolated incident, it's an annual recurrence, a predictable cycle of destruction, driven by forces beyond natural tides. So, what is the prime suspect in this ocean mystery? Where does the finger of scientific inquiry point? To truly understand the origin of the Gulf's oxygen apocalypse, we must look far inland, thousands of miles from the shimmering waters of the Gulf itself. The culprit, as overwhelmingly identified by decades of research, lies in the vast agricultural heartland of America, specifically the sprawling Mississippi River Basin. This colossal river system, draining over 41% of the contiguous United States, acts as a plumbing system, carrying more than just water to the Gulf. It carries something far more insidious, an immense load of nutrients. Primarily nitrogen and phosphorus, these elements are essential for plant growth and are found in agricultural fertilizers, urban runoff, and wastewater discharges. When heavy rains wash these nutrients from fields and cities into tributaries, they eventually make their way into the mighty Mississippi. From there, it's a direct, unstoppable journey to the Gulf of Mexico. This inflow of excess nutrients fuels an explosion of microscopic marine plants, known as phytoplankton. This is what scientists call an algal bloom. While algae are natural, an overabundance is deadly. The mystery deepens when we consider the chain reaction these blooms unleash. Once the massive algal blooms consume all available nutrients, they begin to die. Their decaying organic matter sinks to the bottom, becoming a feast for oxygen-consuming bacteria. These bacteria multiply rapidly, feasting on the decaying biomass, and in doing so, they deplete the oxygen dissolved in the bottom layers of the water column. The deeper, colder, salter water at the bottom doesn't mix easily with the warmer, oxygen-rich surface water, especially in the calm summer months. This stratification creates a suffocating trap. Bottom-dwelling creatures, shrimp, crabs, oysters, many species of fish, are literally starved of breath. They either flee to oxygenated waters, if they can, or they perish. For those that can't escape, the outcome is fatal. This isn't just about individual deaths, it's about the collapse of entire ecosystems. Commercial fisheries, once a vibrant economic engine for Gulf states, face devastating losses. Shrimpers pull up empty nets. Crabbers find their traps devoid of life. What was once a thriving habitat for countless species becomes a biological desert, a ghost town beneath the waves. The economic impact alone is estimated in the hundreds of millions of dollars annually, a stark reminder that environmental mysteries often carry a heavy price tag. Given the clear scientific consensus on the dead zone's cause, why does this annual tragedy persist? Why haven't we solved this mystery? The path to remediation is fraught with complexity, pitting economic interests against ecological imperatives. Various strategies have been proposed and, in some cases, cautiously implemented. Reducing fertilizer use through more precise application techniques, planting buffer strips along rivers to absorb runoff, restoring wetlands that naturally filter nutrients, and improving wastewater treatment are all part of the scientific prescription. However, these solutions require massive shifts in agricultural practices across multiple states, significant infrastructure investment, and cooperation among diverse stakeholders. Farmers, facing tight margins, are resistant to changes that might impact crop yields. Political will across states in the Mississippi River Basin is often fragmented. The Hypoxia Task Force, a multi-agency federal-state partnership, has set ambitious goals to reduce the size of the dead zone, yet progress has been frustratingly slow. Analyzing these efforts critically reveals a profound challenge: the sheer scale of the agricultural system and the economic dependencies built around it make rapid, comprehensive change incredibly difficult. It's a classic case of shared responsibility, where the collective impact of individual actions upstream creates a crisis downstream, making a unified solution feel perpetually out of reach. So, where do we stand with the Gulf of Mexico dead zone? Is it a mystery solved, but a problem unresolved? Or are there still deeper layers to this environmental enigma? The seasonal nature of the dead zone, shrinking in winter and expanding in summer, offers a glimmer of hope that the ecosystem can rebound, if only the oxygen returns. But what are the long-term, subtle shifts occurring in the species that manage to survive or adapt to these annual fluctuations? Are we inadvertently selecting for hypoxia-tolerant organisms, fundamentally altering the biodiversity of the Gulf? What are the implications for the future of commercial fishing, and for the delicate balance of one of the world's most productive marine environments? This isn't just a regional issue. Dead zones are appearing in coastal areas worldwide, from the Baltic Sea to the Chesapeake Bay, suggesting a global pattern of nutrient pollution. The Gulf of Mexico dead zone stands as a stark warning, a living case file on the devastating consequences of human activity on our oceans. Can we truly reverse this silent apocalypse, or are we witnessing the slow, agonizing death of vital marine habitats, a mystery whose ultimate ending remains terrifyingly unwritten? The answers, it seems, will depend on our collective will to act, to understand, and to protect the fragile blue heart of our planet. The case remains open.